next speakers, it's Kajsa Dahlberg and Julien Genetier from Alfa Laval. They will speak about the dual actions needed to decarbonize and how partnerships can accelerate sustainable solutions in green hydrogen. Kajsa and Julien. Thank you.
Thanks a lot, Hans, and thanks a lot to the Swedish American Chamber of Commerce for inviting us. The third time in a row that we get the pleasure to be joining with different type of expertise. Yes, as you have said, Hans, we will be two speakers today. So my name is Julien Genetier, and I'm Vice President of the Energy Division, and I'm together with Kajsa Dahlberg.
Yes. Let's see. I don't know if I'm.
You're presenting, but we can only see the first slide, Kajsa.
Yeah. Okay, that's good. Good at least, because my screen here on the Zoom meeting is disappearing. But you see the slide correctly then. So yes. We go ahead. Good.
And Kajsa, you're coming as industry manager for hydrogen.
Yeah, sorry. Now I missed the introduction here a little bit. Yes, exactly. But we have that on the next slide. So let's dig into that one directly, right?
Correct. So you're coming in as industry manager for hydrogen, and I'm as vice president of the energy division. Before jumping into hydrogen, which is the main topic of our presentation, as you have alluded on, I wanted to highlight the picture on how we see the dual challenge of decarbonization. And on this slide, we can see this dual challenge. By 2050, the raw demand of energy will be increasing by some 54% on the top of what it is today. And at the same time, we have all committed to reduce our carbon emission and reach net zero by the same time. So it's in a way a different picture or a different way of presenting the challenge that Lane and Congressman Mike Levin introduced earlier in this presentation. When it comes to the solution, and that's on the next slide, we can see that there is no one solution that will solve all the problems. And that was mentioned by some of the speakers before, and we could see that many of us and throughout this conference we will see many different solutions that will contribute to that. We've summarized it for ourselves into 3 blocks. The first one is to work with energy efficiency, and I'll come back to a bit more detail about that, which is with ready-made available solution, an opportunity to reduce the net demand of energy. And at the same time, working on new technology and new solution in order to develop clean molecules and drive a massive electrification. So those are the 3-folded group of different solutions that will be needed in our view to reach the sustainable development scenario here painted by Bloomberg and taking over some hypotheses from the IEA. Some few words about Alfa Laval. Laval is a global industrial company headquartered in Lund in Sweden. And we are operating with 3 main technologies. We are leading in 3 of them. It's fluid handling, it's heat transfer, and separation technologies. With these 3 technologies, we are working in 2 ways to address this challenge. On the next slide, we can see that we are working first on making existing industry sustainable, using already existing and available technologies in order to drive mainly energy efficiency and reduce the net demand for energy. And at the same time, we're working together with many partners, and we could see that there's many more partnership to be formed in order to bring to technology readiness the transition to clean energy sources through both innovation and circular economy. So that's how we work at Alfa Laval, and to mention some few words about energy efficiency and how much is the impact today on with already existing solution today. Alfa Laval deliver heat exchangers that enable a reduction of energy saving capacity of 50 gigawatt every year. This is the equivalent of the emission of 25 million tons of CO2 emission reduction, 10 million households, and the equivalent emission of a city like Paris. So that's on the energy efficiency. And now, after this introduction word, I would like to hand over to Kaisa on more how we work on clean energy sources, on the development of those new clean energy sources and the variety of them, but with a big focus on hydrogen, obviously, today.
Yes, exactly. So moving here into the clean energy area, we see, of course, a lot of growing applications. And at Alfa Laval, we are very excited to be an enabler for the transformation of this energy landscape that we have ahead of us. So with our heat transfer and separation technologies, we can support our customers around the world with developing and optimizing their solutions within the clean energy area. And here we see some examples of where we today support customers in these growing applications. But of course, we will specifically touch upon green hydrogen, where we see a massive focus and deployment today. So why is this taking off right now? It's of course driven by the urgent need to decarbonize and the fact that the availability of renewables, such as solar, PV, and wind, has increased significantly and is today also the fastest growing energy source. And this is due to the cost of solar, PV, and wind has reduced significantly the last 10 years. Also, 2/3 of the global populations is living where renewables are the cheapest new power generation option. So as Julian here explained, not only do we see a massive electrification of the society, but we also need clean molecules in order to secure our energy supply. And one of those molecules could be green hydrogen, which is then produced from renewable power. So as hydrogen is a versatile energy carrier, it has the potential to be used in many different end-use applications, as we have heard here before as well. And considering then that it's clean, produced as green or blue hydrogen, it can be a clean energy source. So it can be a fuel within the transportation sector or power for electricity peaking plants, as well as backup generators for any type of industry or application. It can be utilized as heat within the industry or building sector, and especially as feedstock for chemical production, where we will find fertilizers as one of the main applications where green hydrogen will be a necessity to decarbonize. It will also be highly important in the decarbonization of the production of different products, such as steel, that we heard there from SSAB earlier. So having a look at the green hydrogen value chain, what you see here is a very simplified illustration, and it's just intended to give you an overall understanding of the general process. So we have a quick walkthrough. We have two input streams, renewable power and water. They are splitting the water into hydrogen and oxygen, and the chemical reaction is producing a lot of waste heat. And the waste heat is about 20 to 40% of the electrolyzer capacity. So 20 to 40% is actually turned into waste heat. So the electrolyte needs to be cooled off in order to optimize the efficiency of the electrolyzer, and the hydrogen and oxygen also needs to be cooled off. The hydrogen itself needs to also be purified and compressed before transportation, distribution, and storage. And out then to the right, we reach the different end-use applications, as you saw there on the previous slide. So going back to the intro here from Julian, making use of the waste heat in industrial processes is of course important to not only make the existing industry more sustainable for energy efficiency, we are as dependent on making sure that the new technologies that we develop are as efficient as possible. So how can we make use of the waste heat generated in the electrolyzer? One option is of course to reuse it as heat in the industry or through district heating. However, it is a rather low temperature heat that we have, and an option is also to utilize the heat directly to the production of water going into the electrolysis process. Because the water going into the electrolyzer needs to have a certain pureness to secure an efficient process within the electrolyzer and also prolong the lifetime of the equipment. So here the treatment needed depends on the water quality, of course, and that differs if we're talking onshore or offshore hydrogen production, for example. But anyhow, the water needs to be demineralized. And here, Alfa Laval has a solution with our freshwater generators, which is a thermal desalination method that we normally utilize at offshore oil and gas platforms, but it's directly applicable for hydrogen production, and especially then favorable offshore, but also applicable onshore. So with this technology, we can reach the quality needed, and in the majority of the cases, without any post-treatment of the water. So with thermal desalination, we can directly get an offset for the rather low temp heat that is generated in the electrolyte cooling, which means we are improving the overall energy efficiency of the production process. And this is one example of where Alfa Laval equipment comes into play in the hydrogen value chain. But to give you the full idea of where the Alfa Laval heat transfer equipment is applicable, it's actually throughout the entire process. So apart from the thermal desalination of the water, we also work with the cooling of the electrolyte. And as an example, we have supplied the heat exchanger that actually is installed in the electrolyzer module that is installed at hybrids, producing the green steel. So there is an Alfa Laval heat exchanger. And looking out to the right here at the end use applications, there is a need for heating or cooling in more or less any of the processes. Especially then in the fuel part, the pressure becomes very high. And here we have technology to handle these high pressures and demanding circumstances. As an example, we have our printed circuit heat exchanger, which is a compact and efficient solution for cooling in refueling stations. And the refueling stations infrastructure is growing in specific regions around the world. And I know that California is one of these, where we see the dedicated deployment of fuel cell electrical vehicles. Another example is that we work within fuel cell systems. With our technology that can handle the very high temperatures, we are able to support efficient heat transfer in the fuel cell systems where hydrogen then is converted back into electricity. So this is giving the overall general picture of the relevance for Alfa Laval in the hydrogen value chain. And I'm not planning to go into more details than this. Happy to discuss further, of course. But I want to bring up an example, because we believe if we're going to act fast and make sure this energy transition are done in order to reach net zero by 2050, we need to collaborate cross borders to make things happen. And we believe that this is done in partnerships. So one example of a partnership that we are involved in is the Liquid Wind Partnership Consortium. Liquid Wind is a power-to-fuel company which develops and finances the commercial scale e-methanol facilities. So each facility captures and concentrates biogenic carbon dioxide emissions from industry and combines it with green hydrogen to produce green methanol, which then can be primarily used within shipping. And here we at Alfa Laval has acquired a small stake in this company, and we have joined the consortium together with Carbon Clean, Siemens Energy, and Haldor Topsoe. So based on our expertise in the energy efficiency or within energy efficiency and optimization, we are part of the board, and we are contributing to the design of these facilities where the heat exchangers will be installed as a key component in the main system. And it will of course also be utilized in the process steps where we produce green hydrogen and also for carbon capture, and then the specific methanol production. The first plant for liquid wind is actually planned to be built in Sweden, starting their production of e-methanol during 2024. One plant is expected to produce 50,000 tons of e-methanol each year. And by 2030, it's expected to be 10 plants in operations globally. So that was an example of how we can work in partnerships. So just to summarize, green hydrogen is one part of how we enable the transition into clean energy. But as we have heard here, we also have a dedicated focus on how to make the existing industry more sustainable through energy efficiency in order to speed up the pace of decarbonization. We also work with solutions for circular economy. And we strongly believe that all of this work needs to be surrounded by sustainable partnerships. We need to work in collaboration with others across sectors and across borders, both to enable the transformation for our customers, but of course also to reach our own sustainability targets. So with that quick walkthrough, Julian and I want to say thank you, and we hope that you want to join us in accelerating sustainable solutions.